Hi, welcome to Nepal Digital Education. Today in this video series, we are going to start the numericals of force of class 10. But before solving this numerical problem, we must have the idea about one formula. Think what is that formula? That is RGCFS. R R G C F yes, RGCFS. R means read, means first of all read the question, then whatever given in the question first of all write, then change that given into SI system. C means convert, so convert the given into SI system, then write the formula related to this question, then solve it. When we use this formula RGCFS, then there will be less chance of committing mistake. So let us look at the problem first. So radius of the earth is given 6.4 into 10 to the power 3 kilometer. So we know this radius means distance, the SI unit of distance in meter. So first of all, change this into SI system 6.4 into 10 to the power 6 meter. So next, and the value of acceleration due to gravity on its surface is 9.8. So G is 9.8. And find the value of acceleration due to gravity produced on a meteor. So suppose here G dash, we have to find the G dash produced on the meteor at a distance means height is given 9850, so it is h the value. So suppose this is earth and r is given, radius is given, r is given, so in this case r is given, so in this case G become gm by r square. R is given, and there is meteor of height, G dash become gm by r plus h whole square. When we divide both, then we will get G dash equal to G r by r plus h whole square, where this G dash is acceleration due to gravity at certain height from the earth surface, this, and this G is acceleration due to gravity of the surface of the earth, and r is the radius and s is the height from the surface of the earth. So in first case G become gm by r square, and in second case G dash become gm by r plus h whole square. So our equation first is G equal to gm by r square, and second equation is G dash equal to gm by r plus h whole square. Now dividing equation the second by first, so when we divide this equation second by first, G dash by G equal to gm by r plus h whole square by gm by r square. So next step, gm by r plus h whole square into r square by gm, means it is in division. So when we change into multiplication, then it become reciprocal, r square by gm. So this gm cancel, and it become r square by r plus h whole square. So finally it become g dash equal to g r by r plus h whole square. So the value of g is 9.8, and the radius is 6.4 into 10 to the power 6, and here radius is 6.4 into 10 to the power 6, and height is 989850 whole square. So 9.8, and solve this, and you will get here 0.998 whole square. Then just first of all solve this 0.998 whole square, then multiply with 9.8, then it become 9.76 meter per square second. So this is the required value, that is g dash equal to 9.76. This is the required value of acceleration produced on a meteor. Let us look at the problem second. A stone is dropped freely from 45-meter height of the tower. So h is given 45 meter. It reaches the ground in 3 seconds. So time is given 3 seconds. Calculate the acceleration due to gravity of that stone. So we have to find the value of g. So a stone is dropped. So suppose this is a stone, and a stone is dropped freely from 45-meter height of the tower. From a 45-meter height of the tower, stone is dropped. So height is given, h is given 45, and here time is given 3 seconds. And we know that when a body falls freely from its rest state from a height, then initial velocity become 0. So u is 0. So we have equation of the motion s equal to ut plus half at square, but in this case we have height h. So this equation become this s equal to ut plus half at square. In height case it become h equal to ut plus half gt square. So we have h, and height is given 45. Initial velocity is 0. So 0 into t plus half. We have to find the value of g, and t is given. Time is 3. So 3 square. So after this step, 45, 0 into t, 0 plus half g into 3 square, 9. So next step is 45 equal to half g into 9. So 45 into 2 equal to g into 9. 45 into 2, 90. Then next step, it is in multiplication. So it comes in division, then it becomes g equal to 10, and the unit of g is meter per square second. So this is the required value of g, that is acceleration due to the gravity of that stone. So this is the required value of g. Let us look at the problem third. The mass of the Jupiter is 1.9 into 10 to the power 7 kg and its radius is 7.1 into 10 to the power 4 kilometer. Calculate the acceleration due to gravity on the surface of the Jupiter. So we have to find the value of g, acceleration due to gravity, and the mass is given and radius is given, but the radius is in kilometer. So first of all change in meter, just multiply with 1000 and it change into meter. So it becomes 7.1 into 10 to the power 7 meter. And we have to find the value of g, acceleration due to gravity on the surface of Jupiter. And there is second case also. What will be the weight of the person of mass 85 kg? So mass is given and we have to find the weight of the person. So weight W equal to what? So first of all find the value of g, and we have m/r and we have to find the value of g. So we have g equal to gm by r square, and we know that this g is gravitational constant and the value is fixed, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square, and mass of the Jupiter is 1.9 into 10 to the power 27, and the value of r, radius is 7.1 into 10 to the power 7 whole square. So solve it. So first of all arrange 6.67 into 1.9 into 10 to the power minus 11 into 10 to the power 27. So it is 10 to the power 27, and the value of r is 7.1 whole square, means 7.1 into 7.1 into 10 to the power 7 whole square, means 10 to the power 7 into 10 to the power 7. So solve it. First of all multiply 6.7 into 1.9, then it become 12.673, and 10 to the power minus 11 into 10 to the power 27, it become 10 to the power minus 11 plus 27. We all know that the rules of indices, that is x power a into x power b, then it become x power a plus b. It is the rule of indices. So it become minus 11 plus 27, and multiply this 7.1 into 7.1, so it become 50.41, and here base same, then 7 plus 7, then divide 12 point, first of all divide this 12.673 divide 50.41, so become 2.513 into 10 to the power minus 1, and we have 10 to the power minus 11 plus 27, it become 16 plus 16, and this 7 14, then minus 14. We have rules x power a by x power b, then it become x power a minus b. So 10 to the power this plus 7 become 14. Then according to indices rule it become 16 minus 14. So solve it. 2.513 into 10 to the power minus 1 into here 10 to the power 2. So again base same, then it will 10 to the power minus 1 plus 2. So it become 2.513 into 10 to the power 1. So finally it become 25. When we multiply this term, then we get 25.13. What is the unit of G? Meter per square second. So this is the required value of G, acceleration due to gravity. Therefore G equal to 25.13 meter per square second. But we have to find the weight also. So we know that weight equal to mg, and the mass is given. Mass is 85 and we have to find the weight of the person. So mass is 85. Mass is 85 and G is 25.13. So multiply it. We get 2136.05 weight. The unit of weight is Newton. So this is required weight. This is the required weight of the person of mass 85 kg on that planet. So let us look at the problem. If the mass and the radius of the earth are this and this respectively, find the height of meteor from the earth's surface where its acceleration due to gravity become this much. So we have to find the height of meteor. So first of all, draw the diagram. Suppose this is earth and this is meteor. Suppose here height h, and suppose this is radius r is given, mass is given. We have to find the h, and g is also given here. G is also given, that is 4. So mass and the radius of the earth are given, and we have to find the height of the meteor. This height of the meteor from this earth surface where its acceleration due to gravity become 4. G is given. So in this height case we have formula G equal to gm by r plus h whole square. So we have the value of G. G is 4, and we know that this capital G is gravitational constant and its value is fixed, that is 6.67 into 10 to the power minus 11 into mass. Mass is 6 into 10 to the power 24, and r is 6. Radius is 6.4 into, here radius is given meter, so first of all kilometer, so first of all change into meter, so it become 10 to the power 6 meter, because the unit of this distance is meter. So first of all change into meter, just by multiplying 1000 it converted into meter. So here radius is 6.4 into 10 to the power 6 plus height, we have to find this height h whole square. here 4 equal to, first of all arrange this number, it is easy to solve. 6.67 into 6 into 10 to the power minus 11 into 10 to the power 24, and here 6.4 into 10 to the power 6 plus h whole square. So next step, just do cross multiplication. 4 into 6.4 into 10 to the power 6 plus h whole square equal to, multiply this 6.67 into 6, so it become 40.02 into 10 to the power, it become minus 11 plus 24. We have rules, indices rules, x power a into x power b, then it become x power a plus b. So it is the rule of indices. So here now, yes, write 6.4 into 10 to the power 6 plus h whole square equal to 40.02 divide, it is in multiplication, so here we write in divide into 10 to the power, subtract it, plus minus minus, so it become 13 plus 13. First of all divide this 40.02 divide 4, so it is coming 10 into 10 to the power 13. So here base same, so power should be added, 1 plus 13, it become 14. Here we have 6.4 into 10 to the power 6 plus h whole square. This square, when you remove this, then it become in the root 6.4 into 10 to the power 6 plus h. Here is equal to, it become root 10 to the power 7 minus, it is in what, plus, so when we bring this side, and it become what, minus 6.4 into 10 to the power 6. So solve it, this 10 to the power 7 means 1 2 3 4 5 6 7, minus this means 6 4 1 2 3 4 5, so required value of h. So this is the required height, therefore required height is 1 2 3 4 5 meter. We can also write 3600 kilometer, both are right. So this is the required height of the meteor from the earth surface. Let us look at the next problem, problem number 5. The radius of the earth is 6380 kilometer. Radius is given 6380 kilometer. So first of all change this into meter. So 6380 into 1000. So it become 6381240 meter, because we know that the SI unit of distance is meter, and the height of the Mount Everest, H is given 8848 meter, so height is given 8848 meter. If the value of acceleration due to gravity on the top of Mount Everest, on the top of Mount Everest, suppose this acceleration due to gravity be g dash, that is 9.77 meter per square second. Calculate the value of acceleration due to gravity on the surface of the earth. So g, we have to find the g. What is the weight of the body? So this is second case. In second case, we have to find the weight, and the condition is mass is given 50 kg. So first of all, solve the first case. In first case, we have r h g dash, and we have to find the g. So in this case, we have formula g dash by g equal to r by r plus h whole square. We have to find the value of this g. So we can also write this g by g dash equal to r plus h by r whole square, because it is easy to find the value of g. So it become g dash r plus h by r whole square. Then the value of g dash is given 9.77. So g dash is 9.77, 9.77, and the radius is given 638 and 40, 1 2 3 40, plus height is given 8848, and the radius is 638 1 2 3 40 here whole square, 63840, it is right. So first of all, solve this term. First of all, add, then divide, and then square it. So we get this into 1.002. Just multiply it, and we get the value 9.78. We can also write here 9.8 meter per square second, because the unit of g is meter per square second. But in second case, we have mass of the body 50 kg, and we have to find the weight of the body on the top of the Mount Everest. So on the top of the Mount Everest, g dash is 9.77, and we know that weight equal to mg. So mass is given 50 kg. Mass is given 50 kg, and on the top of the Mount Everest, this g is 9.77. Just multiply it, 488.5, and the unit of weight is Newton. So this is the required weight of a body of mass 50 kg on the top of the Mount Everest. Let us look at the problem 6. The radius of the earth is 6.4 into 10 power 3 kilometer. So first of all, change this into meter. So 6.4 into 10 to the power 3 into again 10 to the power 3. So it become 6.4 into 10 to the power 6 meter, and we can also write here 6 4 1 2 3 4 5. When we multiply this term, then we get the value this meter. So this is the required radius of the earth, and the height of the Mount Everest is 8848 meter. So if the value of acceleration due to gravity at the surface of the earth, so G is given this 9.8 meter per square second. Calculate the value of G at the top. So we have to find the G dash. But in the previous video, we find the value of G. But in this video, we have to find the value of G dash. So just by using the same formula, we get the value of G dash. So we have G dash by G equal to R by R plus H whole square. So we have to find the value of this G dash. So G dash equal to G into R by R plus H whole square. So the value of the G is given 9.8 into, and the value of the R is 6 4 and 50. 1 2 3 4 50 by, again, radius is 6 4 1 2 3 4 50 plus, and height is 8848 8848 here whole square. So 9.8 into 6 4 1 2 3 4 5. First of all, add this term and we will get 640 640 640 8848 8848 whole square. 9.8 into, yes, divide this term. First of all, divide, then square, then we will get 0.9975. So just multiply it and we will get the value 9.77. This is the required value of G dash, and we know that the unit of G is meter per square second. So this is the required value of G dash, that is the value of. Let us look at the problem 7. Find the acceleration due to gravity on the top of the Mount Everest. So we have to find the G dash here, or we can also write G only. So we have to find the value of G. If it is 8848 meter above the sea level, so height is given 8848 meter. The radius of the earth is 6400 kilometer. So first of all, change this into meter. So it becomes 6400 into 1000. So the required value is 64123450 meter. So this is the required value of R, and its mass is given. So we have radius, mass, height, and we have to find the value of G. So in this case, we have formula G equal to Gm by R plus H whole square. So we know that this G is gravitational constant and its value is fixed, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square, and the mass is 6 into 10 to the power 24 by R. Radius is 64123450 plus height is 8848. and here whole square. So next step, first of all arrange this 6.67 into 6 and 10 power in one place, this into 10 to the power 24. First of all add this term, then it become 6408848 whole square. So when we multiply 6.67 into 6, then required value is 14.02 into, here base is same, 10 power minus 11, 10 power 24, base is same, so power should be added. Then this 6408848 whole square, when we multiply this twice, then we get the value 6 point, yes. So when we multiply this twice, then we get 4.1071073 into 10 to the power 13. So 40.02 divide 4.10733 into, here 10 to the power minus 11 plus 24 and this 13 minus 13. We have the rule of indices x power a by x power b, then when base is same, then it should be subtracted, a minus b. So this is x power a and x power b, so it become minus 13. So first of all divide this term, 40.02 divide 4.10733, 40.02 divide 4.10733. So the required value is 9.7, and here 10 to the power, here minus minus plus, so 314 24 minus 24 plus 24, it cancelled. 9.7 into this plus minus cancel, 10 to the power 0, so it become 9.7 into 10 to the power 0 means 1. We have indices rule x power 0 means 1, so it become 9.7. This is the required value of g, and we know that the assignment of g is meter per square second. So this is the required value of g, acceleration due to gravity at the top of the Mount Everest. Yes, let us look at the problem 8. The mass of the sun is 2 into 10 to the power 30 kg. That of the earth is 6 into 10 to the power 24 kg. And the distance between them is 1.5 into 10 to the power 8 kilometer. So first of all change this into meter. 1.5 into 10 to the power 8 into 10 to the power 3. So it become 1.5 into 10 to the power 11 meter. Now what is the gravitational force produced between them? Gravitational force produced between them, and g, gravitational constant, is given 6.67 into 10 to the power minus 11 Newton meter square per kg square. So we have to find the gravitational force. So first of all, what is gravitational force? So simply suppose this is body first and this is second, and according to our question our first body is sun. Suppose this is sun, and next body is earth. This is earth. Our force exists is F. Suppose your mass is m1, your mass is m2, and force is F, and your distance is d. So we have to find the gravitational force, and we all know that gravitational force states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So according to this statement, this force is directly proportional to product of their masses m1 and m2 and inversely proportional to square of their distance. So when we combine this both equation, then we get F directly proportional to m1 by m1 m2 by d square. When we remove this proportionality sign, then we have to add here one constant, that is capital G, gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Here m1 m2, here d square. So this is the required gravitational force. Just by using this formula, we will be able to solve this problem. So let us look at the problem. So we have to find the gravitational force, that is F, and F equal to G m1 m2 by d square. So the value of the G is 6.67 into 10 to the power minus 11, and m1 and mass m1 is given 2 into 10 to the power 30, and m2 is given 6 into 10 to the power 24 by distance is given 1.5 into 10 to the power 11 d square whole square. So first of all, arrange all the numbers 6.67 into 2 into 6 and arrange this 10 power in one place, minus 11, 10 to the power 30, and 10 to the power 24. And here 1.5 whole square means 1.5 into 1.5. Here also we have 10 to the power 11, so it means 10 to the power 11 into 10 to the power 11. So multiply this term 6.67 into 2 into 6, then we get 80.04 into, here base is same, so it become minus 11 plus 30 plus 24. Here 1.5 into 1.5, it become 2.25 into 10 to the power, here base is same, so power should be added. Next, first of all, divide this term, this 80.04 divide 2.25, then we get 35.577 into 10 to the power, just solve it, this plus 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 54 minus 11 43, and here 11 22, so it become minus 22. 35.57 into 10 to the power, plus minus minus 43 minus 22, it become 21. But we can write here 3.557 into 10 to the power 1 into 10 to the power 21. When we change into this scientific, when this decimal replaces in left side, so power should be positive. When this should be moved right side, then it should be negative. So again we have here same base, so 21 plus 1 22. So this is the required value of force, and we know that the unit of force is Newton. So this is the required value of F, that is gravitational force produced between them, that is F equal to, therefore F equal to 3.557 into 10 to the power 22 Newton. So let us look at the problem 9. The mass of the Jupiter is 1.9 into 10 to the power 27 kg, and the radius is 7.1 into 10 to the power 4 kilometer. So first of all change into meter. So it become 7.1 into 10 to the power 7 meter. Calculate the acceleration due to gravity. So we have to find the value of g. What will be the weight of the person? It is second case. What will be the weight of the person of mass 85 kg on that planet? So this is our case second. Case second. So in first case we have r, m, and we have to find the value of g. So we have formula g equal to, in first case g equal to gm by r square. So we know that the value of this capital G is fixed, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So 6.67 into 10 to the power minus 11 into mass is 1.9 into 10 to the power 27 divide here r square. Radius is 7.1 into 10 to the power 7 whole square. So solve it. First of all arrange. So first of all arrange it. 6.67 into 1.9 and 10 to the power minus 11 into 10 to the power 27. Here 7.1 whole square means 7.1 into 7.1, and here 10 to the power 7 square means 10 to the power 7 into 10 to the power 7. So just multiply this term 6.67 into 1.9. So required value is 12.673, and here base is same, so power should be added, and here 7.1 into 7.1, so required value is 50.41, and here also base is same, so become 7 plus 7. So first of all divide this term, 12.673 divide 50.41. So the required value is 2.513 into 10 to the power minus 1. Again here we have 27 plus minus minus 27 minus 27 minus 11, 10 to the power, it become 7 minus 1 6, 1 16, so it become 16, and this 10 to the power 7 plus 7 14, so it should be subtracted 7 7 14, so it become 2.513 into 10 to the power minus 1, and this here 6 16 minus 14, 10 to the power 2, so plus 2, here 2.513 into 10 to the power plus minus minus, so it become 1. So when we multiply this term 2.513 into 10, 10, so it become 25.13. So this is the required value of g. So we all know that, we know that the value of g is meter per square second. This is the required value of g, but we have second case also. Mass of the person is 85 and we have to find the weight, so this is case second. So we know that weight equal to mg. So mass is given 85 kg, 85, and the value of g is 25.13. so when we multiply 85 into 25.13, so the required value is 213.2136.05. This is required weight. So this is the required weight of a person of mass 85 kg on that planet. Let us look at the next problem, problem number 10. The mass of the earth is 6 into 10 to the power 24 kg and the radius is 6400 kilometer. So first of all, change this into meter into SI system. 6400 into 1000, so it becomes 641234 meter. What will be the acceleration due to gravity at the distance of 3600 km far from the earth's surface? Means we have to find the acceleration due to gravity at this height. So we have to find the value of g, and height is given 3600. First of all, change this into SI system in meter, so it become 3600 meter. So radius and the mass of the earth is given. Suppose this is radius r, so r is given and mass of the earth is given at this height 3600 height. What will be the value of g? We have to find this g, and the height is given, h is given, and we have to find the g. So in this case we have formula g equal to gm by r plus h whole square. So this capital G is gravitational constant and its value is fixed, that is 6.67 into 10 to the power minus 11 into mass is 6 into 10 to the power 24. Here r is 64123450 plus height is 36123450, this whole square. So first of all, arrange it 6.6.67 into 6 into 10 to the power minus 11 into 10 to the power 24. First of all, add this 6450 plus 36, this 50. First of all, add this value and square it, and you will get 10 to the power this 7 and this whole square. So first of all, multiply this 6.67 into 6, it become 40.02 into here base is same, so power should be added, and here 10 power 7 whole square means 10 power 7 plus 10 power 7, so 40.02 into 10 to the power here plus minus 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 11 plus 24, so it become 13 and this 7 14, so minus 14 here 40.02 into 10 to the power minus 1. So 40, we can also write this as 4.002 into 10 to the power 1 into 10 to the power minus 1. When we shift this point left side, then power should be positive. So this is 10 power 1, because when here we shifted 1 unit only, so it is 10 power 1, so this is cancelled, means base is same, so power should be added, plus minus minus 10 power 0, so it become 10 power 0 1. So here 10 power 0 0 2 into 1, it become 4.002. So here base is same, so added 10 power 0, so it become 1. So this is required value of G, and the unit of G is meter per square second. Here meter per square second, this is the required value of G. Let us look at the problem. In the figure, two identical metal ball A and B. Suppose this is A and this is B. Two identical metal ball having equal mass. So mass is given 45. Equal mass 45 kg, and here also 45 kg. So equal mass are being dropped toward the surface of the moon and the earth. Being dropped toward the surface of the moon and the surface of the earth. There are two cases. Here surface of the moon. So in this case G is 1.66 meter per square second, and in second case here G is 9.8 meter per square second. Analyze the given data and answer the following question. In question number first, if both the metal balls are released simultaneously, which one does strike the ground faster? So with calculation. So in this case, initial value is what? 0. In this we have the equation of motion, S equal to ut plus half at square. But in this height case, this equation become S equal to ut plus half gt square. But when these two metal ball dropped toward the surface of the moon and the earth, so initially its velocity is 0. So this equation first become S equal to 0 into t 0. So here this equation become half gt square. So in case first this moon, in case first, in case first, in case A, height is, and height is also same 50 meter. We have height also here 50 meter height, 50 meter height is also same. So in case A, here height is 50 meter, so 50 equal to half g. We have to find this g, so g into t square, and time, and we have the value of this g. We have this value of the g. Value of g is 1.66, and we have to find the value of here t. So solve it. 50 into 2 equal to 1.66 into t square. So 50 into 2 100 divide 1.66 equal to t square. So here t equal to root under this square, so it become in the root. So 60 here, 60 point, when we divide this term then we get 60.24096 root under. So the required value of t is 7.76 second. But in case second, in case B, height is same 50, half, and g is given 9.8, and find the t square from equation second. Here from equation second, here 50 into 2 equal to 9.8 into t square. So 50 into 200 divide 9.8 equal to t square. So here t equal to root under, first of all divide this term, 100 divide 9.8, then it become 10.20. So root under 10.20, 3.19 second. So in first case time is 7.76 second, and second case we have 3.19 second. So in the question, if both metal ball are released simultaneously, so this take 7 minute and this take 3 minute only, so which one does strike the ground faster? So this B strike the ground faster. So hence B strike the ground faster. So let us look at the second problem. A person lift 60 kg on the surface of the earth. 60 kg. So mass is 60 kg. How much mass can he lift on the surface of the moon? So we have to find the mass he lift on the surface of the moon. So in first case, on the earth surface, first of all find the weight, because we have mass and acceleration. So in this case weight equal to mg, g here acceleration due to gravity, g, mass is given 60, and g acceleration due to gravity is 9.8. so it become, first multiply 60 point, so 60 into 9.8, 588, 588 weight. The unit of weight is Newton. So on the moon, weight become 588 Newton. So now in second case, weight equal to mg, and we have to find the value of mass. So weight by g equal to m, and weight is 588, and the value of the g is 1.66. 1.66 equal to mass. So therefore mass equal to, divide 588 divide 1.66. So required value is 354.21 kg. So this is the required mass a person can lift on the moon surface.